Afternoon, everybody. So I'm from Jersey originally, and I tend to walk around a little bit, but since we got this mic here, I'm going to stay a little close to the podium. Jersey Shore, right down, kind of grew up there, and then MTV happened, and it's not the same anymore. Right? When you run into Snooki at Target, it's not the same, right? Compared to what it was when you grew up as a kid, and it was a family place. It's not quite like that anymore. It's getting back to that. We'll see what it's getting like now after the pandemic, but at least last summer it was a little closer to what I remember as a kid. But recently I moved to Florida just to stay warm all the time. So this isn't the first time I've given this talk. I've been giving this talk for 5+ years. The better part of my career, I've been doing Oracle to Postgres migrations. Started doing them in '04, really '03, and been doing a number of them ever since. And this talk has evolved a little bit over the years as people start learning from some of those mistakes, and now they're making new ones. But still, the core mistakes are still there. I've never came across one where they made all 10 of them, and I've never came across a migration where they didn't make any. Right? There's always a little something there. It's just a matter of what degree that's there. Before we get started, I'm going to try this video and see if the audio picks up. It's just a quick little thing. Let's see if it's...
Do we have a permission to shut down the database?
Are we going to do this?
Yes! 5, 4, 3, 2, 1.
So this was a video taken when the last Oracle database was shut down at Amazon, right? So Amazon was entirely an Oracle shop, and it migrated everything off of Oracle other than a handful of things running Oracle applications. But in total, from the OLTP side, they migrated 7,500 databases off of Oracle, totaling over 75 petabytes of data in the course of a couple years. So whenever you order anything at Amazon, right, it's running in Postgres, right? So the front end stuff is using some NoSQL, DynamoDB, but the fulfillment centers and everything else, everything that handles the shipments and everything, it's running on Postgres. And that was all migrated from Oracle. And they did that in the project over a course of a few years, all the Oracle databases. So it is a very feasible thing if people want to have the will to do so. It requires everything up to the executive management level, where at Amazon, the CEO was paying attention to this project. It's not something you do at the side. In a lot of ways, it's a cultural shift. But if there's a will, you could move off thousands of databases off of Oracle. But why do people make these mistakes? Amazon made some of these mistakes. They made a lot of these mistakes. The biggest reason why is they start the project too late. There's a looming Oracle renewal deadline coming. By the time finance comes around and says, hey, we have this big bill coming, it's not enough time to actually get the project done, so people take shortcuts. Part of it is people don't know Postgres well enough. Right? It's just they haven't gotten the training. They've been Oracle people their whole time. Another is that they only see the world through a lens of being from Oracle. They see a feature that they know in Oracle, they just want to do the exact same thing in Postgres. They don't think of how Postgres does it. And probably the biggest source of that are the migration tools themselves. The migration tools are built to make sure that it gets everything over where it works, not where it works fast, right, or works well. It's just going to work. It's going to check that box to be functional. The first mistake is the dual table. In Oracle, if you ever want to run a function, you have to say from dual, select sysdate from dual. The very Oracle specific thing. What I've seen a lot of people do is mock up the dual table, so this way they don't have to go change all their application code. Right? They'll create a table and put that dummy column in there, and this way they'll go ahead and do the from dual. Problem is, I ran into this actually at a couple customers years ago, is when it's a table, you can insert multiple rows into it. So if you do select sysdate from dual with 2 rows in it, you get 2 results back. And all of a sudden, everything you expected to return back 1 row is now returning back 2, which causes a whole bunch of bugs in your application. So reality is Postgres doesn't need a dual table. The from clause in Postgres is optional. You don't have to put it there. You could just say select current date in order to get back your current date, or current timestamp to get back the timestamp equivalent. Use that as a way to find your Oracle-specific code in your applications. It's a great thing to grep by, looking for dual, right? You could go find all the Oracle-specific stuff and analyze everything. If when doing that, you find out that it's going to be a really big project in order to be able to change all that from dual because you have it scattered everywhere. If you're going to do it, at least do it as a view, so this way you don't run into the problem of adding multiple rows to it. Table spaces. In Oracle, everything is inside of a table space, to the point where people put their indexes in different table spaces from their tables, right? They'll use table spaces all over the place. Postgres has table spaces, but how things are laid out on disk are very different than they are on Oracle, right? So in Postgres, it's just a table space is just a directory location. So if you don't have your things spanning across multiple different volumes on your operating system, a table space isn't going to buy you anything in Postgres. There's zero reason to use table spaces if you just have one mount point. Only if you're going to go across different physical drives elsewhere does table spaces make sense in Postgres. You could do them if you want to, but it makes things like your upgrades and other things and your backups more complicated, right? So it doesn't really buy you anything, so don't do it. I've seen plenty of times where people start of trying to lay out all the table spaces before they even create a table in Postgres. Just use the default table space. It's going to serve you well. Case folding. In Oracle, whenever you have any of the metadata, it folds to uppercase. So if you want to look your people table, all your columns, F name, middle name, last name, are all going to be in uppercase.
Even if they're quoted?
Well, if they're quoted, they're going to follow the. If they're unquoted, then they're going to default to uppercase. If they're if they're quoted, they're going to be whatever you type in. So if you want to use camel case, you could use camel case. Postgres defaults to lowercase. So Postgres tries to follow the ANSI standard ANSI SQL standard for just about everything it does, but it doesn't follow it in this case. The ANSI standard is actually uppercase. Postgres, it defaults everything to lowercase. And I've seen lots of people try to carry that over. A lot of the migration tools will do that. So if everything's in uppercase on Oracle, because that's what it defaults, some of the migration tools will double quote everything and cause it to come over as uppercase. And that just means then you have to double quote everything. Don't do this, right? Even if it means you have to change your application code a little bit, don't do that because it just becomes tedious and error prone. Use the native case folding of the database, the target database that you're using. I've just seen too many latent bugs come up because of people trying to follow the case folding of what it was in Oracle. So failback. So this is something that happens every time. It's really because management says we need to be able to fail back to Oracle if something doesn't go right on Postgres. So what everybody wants to do is set up replication from Oracle to Postgres and then replicate back to Oracle just in case something bad happens. Right? They want to have that failback scenario in order to be able to go back. And they spend an enormous amount of time testing this failback scenario, that if in the event that they have to be able to fail back, they could go back to the Oracle database that was there. So never do that. The amount of effort that you put into that bidirectional replication problem across databases, that's a project just as big as the migration project itself. It becomes a never-ending thing. And the amount of effort and time that you put into setting that up, you're better off putting it into testing, performance testing, spending more time with QA of the migration itself than having that failback scenario, because one of two things happen. is when you fail a switch over to Postgres the first time, if you're going to notice a problem, you're going to notice it immediately. So then you just abort. You abort that switch over. That happens occasionally. The more subtle thing is if it happens a couple weeks later. And in that time when it's a couple weeks later, the amount of effort that you have to use in order to be able to switch back to Oracle compared to just fixing the problem in Postgres, it's minuscule. Right? So you could have a fail forward where you're going to fail. You could have a replication from Oracle to Postgres and then Postgres to another Oracle database, but don't try to go back to the original. Right? Always kind of move forward in your scenario of going forward. That's a lot less effort of setting up. And you don't have to worry about conflicts or anything like that that you have to test for and be able to account for. It becomes a much more complex problem that's there.
Except your license costs double.
Your license costs double temporarily, right?
And
Yeah.
Oracle said that if you, it says, I've been there, if you instantiate somewhere else, you have to pay for the whole year.
Yes. And I've seen thousands of Oracle to Postgres migrations. I've never seen anybody go back to Oracle weeks later. It was never, even when they had a scenario where they were replicating back to Oracle, never once in the 1,000 that I've seen has anybody gone back. So it's always been easier to fix the problem in Postgres once you're there.
What tools can you do to replicate from Postgres to Oracle? Because the application stream is quite different.
There's plenty of tools that allow you to do that. Golden Gate is one of them, right? If you want to pay for Golden Gate, if you're already paying for that. AWS has a database migration service that allows you to use replication. There's other tools out there too. There's several of them out there that do that, including open source ones.
So is that using statement-based replication or
So it's logical row-based replication. Synonyms.
Then you have problem with nulls.
Well, nulls is another one of the mistakes that are there.
Especially in replication because you can't just find it.
That's exactly, everything you're saying is exactly the reason why it's so much more effort to try to replicate back to Oracle, right? Fix the problem while you stay on Oracle. There's so many corner cases that you have to test for and account for that particular scenario, that if you put that amount of effort into just testing the original migration, you're going to be much better off, right? You're spending all that effort for that what-if scenario that never happens. Synonyms is one of those things where people are seeing everything from the lens of from an Oracle database. I've heard a number of times, Postgres doesn't have synonyms, so I can't migrate there. I use synonyms for everything that I do, right? Really what synonyms are for most people is just a way to avoid fully qualifying your objects, right? Some people, you do some interesting things where they're switching things with maintenance and other things that they're doing. There's a Postgres way to kind of handle all of those, but by and large, almost the reason everybody's doing it is for not fully qualifying your objects. Postgres has a different concept called search path. That it basically is like a directory path on your operating system where it's going to follow along these schemas that you put in your search path until it finds the object it's looking for. Right? So by default, it's going to be $user, public. So if you have a schema named as the same user, so if there's a gym schema and I log in, it's going to first look in the gym schema. If I go select star from foo, right? It's going to look inside the gym schema first. If not, it's going to look in the public schema, right? By default. So here we got a couple sample functions. So in Postgres, there's a bunch of different stored procedural languages you could do. This one is a SQL stored procedural language. This is really the way this works. I think of it like a macro at the SQL level. This is replaced at parse time. So it's a really fast way to do it if you have very simple functions. But we create a couple of them. User1.getInt, user2.getInt, and a public.getNumber. And all they're doing is returning back 1, 2, or 3.14. Right? So if we just try to run that function, select getInt, by default, it's not going to find anything. Right? Throws an error, doesn't look. We set our search path. Search path can be set at the session level, at the user level, at the database level, or globally throughout the whole instance. We set our search path to user1, user2, public. When we try to run the getInt function, we get the number 1. We change that search path to user 2, user 1, public. We get the number 2. It follows along that path. And if we just try to run get number, it's in the public schema, so it's going to find it running 3.14. Right? It's a lot easier to manage your fully qualified things with the search path than it is trying to create synonyms of every object that's there. It's a lot less moving parts in order to be able to get right. And it's very flexible, so this way you can set it at the session level if you need to. Nulls, as we talked about. They are different between Oracle and Postgres. But Postgres does follow the ANSI standard, where Oracle does not. Oracle treats nulls as empty strings. So if we try to run the coalesce function on Oracle with an empty string, we get back the letter A here at the bottom because it thinks an empty string is a null. We do that on the Postgres side. We're going to get back a null because it's empty string, or we get back an empty string because empty string is different than null. It's not null on Postgres. Right? So the usual place we see this in string concatenation. In Postgres, whenever you concatenate a null with anything else, you get a null. Right? Whereas in Oracle, you'll get treated as an empty string. So if we have the people table with first name, middle name, last name, and we run a simple select where we're going to concatenate those 3 columns together, if we run that against Oracle, we're going to get back 10 famous people as it's coming back. If we run that against Postgres, we're only going to get back John F. Kennedy and Martin Luther King. And the rest of them don't have middle names, or at least publicly use middle names like JFK and Martin Luther King. So in Postgres, you'll get those notes. Those are usually, you see those sort of differences very quickly along the way. Okay. So in order to be able to handle that in the Postgres side, you have to coalesce those, right? It's the same as on the Oracle, you'd use NVL. Postgres does have built-in functions that do a lot of these things that you normally won't see in some of the Oracle database, in Oracle, right? So there's a concat WS function that'll handle the nulls. So this way, if that's really what you're doing is concatenating some strings, you could use the built-in function instead of coalescing everything. Depends on what your needs are. The bigger one is around unique constraints and nulls. Right? In Oracle, if you have a unique index on a table, right, if you insert a row in there, we get 1, A, right? Then we get just 1, so column C2 is null. The second time we insert that, we get a unique constraint violation. In Postgres, we do the same thing. We insert 1, A, 1 with null for C2, and we could insert another one. In Postgres, null does not equal null. So this is not a unique key violation, right? Null is nothing, so you can't compare it to nothing, so it doesn't violate. Right? So this is something that's more subtle that comes up that I've seen problems with the migrations, is the null handling in unique constraints. Yeah, right. New in Postgres 15, which is just going beta now, and we'll have a talk about it in a couple hours, is a new concept of saying null's not distinct. So starting in Postgres 15, which should be available in the fall, from September, October timeframe, you could create your indexes coming over from Oracle that will behave more like it does with Oracle. So this way, if we did the same test by creating that index with nulls not distinct, we get 1, A, 1, and then the second time we'll get the unique constraint.
That doesn't help if you insert an empty string, because empty string will not be.
Well, you get that the same thing would happen in Oracle. You'd get the unique, you have 2 empty strings in Oracle, you get a unique constraint violation. So talking about indexing.
But you can still get the empty string and the nulls that is conflicting.
Yeah, yes, you can get that subtle differences there. Where absolutely, they are 2 very different engines. Postgres and Oracle are very different. They may look the same from the surface, but it's like driving a car that's a gasoline engine versus a diesel, right? It's like from a driver standpoint, they're about the same. You put it in gear, you press on the pedal, you go. But when you have to do any sort of maintenance and you go to the gas station to fuel up, you go to a different pump in order to be able to maintain that. And then if you have to do any sort of maintenance under the covers, like tune-ups, it's like diesel engines don't have spark plugs. Things are very different how they're implemented, even though from a user standpoint, they look very similar. Under the covers, they're very different. Nobody that we know of that worked in the internals of Oracle have ever written any Postgres code, right? So it's how they've solved the same sort of problems for unique constraints on indexes is different. How it handles concurrency and other things, they might have similar concepts, but the implementation is very different. So you get different subtle behaviors. So indexing, it's very different. I do get this pretty commonly of, hey, I didn't index that on Oracle, why would I do it on Postgres? Right? When you're moving over your indexes from Oracle to Postgres, about 80 to 90% of them will be the same. There's going to be differences on that last 10, 20%. Sometimes you're going to remove an index, sometimes you're going to add an index. They're not going to be 100% the same because they're implemented different. And Postgres has other indexing types that Oracle doesn't have. And Oracle has some indexing types that Postgres doesn't have. Right? So those sort of things, they're going to be a little bit different. Right? So Postgres by default not only has the B tree, it has hash indexes, gin indexes, bloom indexes, gist, spgist, brin, rum indexes. You could tell Postgres community people are drinkers. There's also a vodka index and other ones that are around. It tends to, these indexes tend to be talked about at Postgres conferences, usually in the evening, and they come up with an idea of it and then they back into the acronym that makes it work. But they do end up being pretty useful. For instance, the Bloom index, if you need to be able to index all the columns in your table, having a Bloom index will be able to do that and keep it still relatively small and not take a huge performance hit because you could index all the columns with a single index. It may not be the most efficient as a B tree in each one, but from a write standpoint, you're only having one index instead of 20, 50, 100 indexes. Right? Something like the Brin index is great for time series data. It's a block range index, so you're indexing the min and max values over a range of blocks. So something that's naturally right-leaning like time series data, the most recent data is always going to be written to the end of the table. Right? That keeps your indexes really small, where you could have it usually 3 orders in magnitude smaller than what a B tree index may be on the same column. Right? Giving really good performance improvements over very large tables. So it really depends on what problem you're trying to solve for that particular type of data. What is that data, the cardinality of that data? There's a lot of different choices there, and it's different how both database engines implement them. A simple example is Postgres' gin index. So if you want to be able to do a simple wildcard search with the wildcard in the beginning and end of a string, Postgres, you can create a gin index on that and do an index scan. You don't have to set up anything complicated like full text search or anything. You just create a gin index on that, and you'll be able to use an index to be able to do that wildcard search. Right? You do pay a little price on the writes because that index is bigger than a B tree index, but depending on what your needs are, that you might be optimizing for the reads versus the writes in that sort of scenario. Right? So when you're migrating over your indexes, don't try to do the one-for-one. Right? You're always going to change out some of those things at the end. Right? When you're performance benchmarking Postgres, after you've migrated your application, you're going to see, hey, this query's slow, that's query slow, or this bulk load job is slow because you have extra indexes on there that you don't need.
Actually, could you go back to the slide because you didn't answer the main question.
What's that?
I didn't index by column in Oracle. Why would I in Postgres? So what does Oracle do so it doesn't need an index?
It runs slow, and it could run faster in Postgres. right? So,
No, but according to this statement, if I interpret, English is not my first language, it's my third.
Yeah.
I would say that Oracle is running faster without indexes.
well, it's running well enough for them, and they've adapted their processes to run at whatever Oracle speed is. So in an example like this one, where they wouldn't have an index on last name, because it's a wildcard search before and after. They would either have something like full text search or something like that in order to be able to do that, or they would just do a full table scan, right? And so if the table's small, it might not matter.
No, but I'm just wondering why Oracle would be faster than Postgres in this particular case. Yeah, that was my question.
Oracle sometimes is faster, sometimes slower, depending. On full table scans, it's a little bit faster because it's smaller on disk than what Postgres is.
Okay, that's answered the question.
Yeah.
Thank you.
I think also like partial indexes are kind of forgotten.
Yeah.
They're not in Oracle, but they are in Postgres, and people tend to forget about them. And
Yeah.
they speed things up, once you take advantage of them in Postgres.
Yeah.
What's the partial index?
It's where you basically index basically on a predicate.
Yeah, on a where,
Predicate of a string.
Yeah.
Okay, thank you.
right, you know, index where is not null. Create index where is not null, of some value is not null. Like if 80% of your values is null, why index them? You'll never use an index when you're looking for something that is null. So why index the 80% of the columns that are there, or rows that are there? You know, keep your indexes smaller, right? It's pretty, in many cases, if the cardinality of a value is more than 25, 30%, the value of the index goes down compared to fully scanning the table. So why index that if that's the bulk of your table? Just keep it out of the index. It'll keep the indexes smaller, which will speed up those indexes in general. So native features, right? So heard this all the time. Part of it is that fear of switching to Oracle, thinking that they may go back. So why? So people are reluctant to use native Postgres features in the migration. You shouldn't try to rewrite your application fully to do everything Postgres native for everything and do everything the same way, right? Because then your migration project will never end. But tactically doing some things in Postgres that are Postgres specific will speed up that migration, because some things are faster to do things natively in Postgres, and it'll give you better performance at the end. So it is a trade-off of understanding when Postgres has that native functionality that you should leverage, and not versus doing everything the Postgres way, right? Because you'll never get to the finish line if you try to do everything the Postgres way for a large Oracle application. Right? So Postgres has a lot of things like data types, custom operators, and other things that give you some advantages over what you may do in Oracle. So simple example here is having a function called has valid keys. So if you needed to validate a JSON document, one of the things that Postgres has is a stored procedure language called PLv8. That's JavaScript stored procedures. So if you're working with something like JSON, which is JavaScript object notation, it's going to be really efficient to do your JSON manipulation inside of JavaScript. So if you needed to validate a JSON document before you write it into your database, you could create a constraint on that document to make sure it has all the valid keys. Because people talk about JSON being schemaless, and it is in a sense, but if it doesn't have keys that your application is dependent on, your application's going to break. So you want to have some sort of validation on that JSON that it's just not some random blob that's in there that'll break your application. So a common thing is to start adding some constraints to those JSON documents to make sure that it has the essential fields in there that your application requires. This one was kind of a fun one. So, 5, 6 years ago, I was helping a customer migrate one of their applications off of Oracle, and they had thousands of lines of PL SQL code written to be able to parse and query IP addresses and and subnets, and be able to find out whether or not an IP address is in a given subnet. And it was several thousand lines of code inside of their in a couple Oracle packages that they were struggling to be able to migrate to Postgres. And I looked at it and looked at what their application was doing it, and what I told them to do is delete it, throw it away. Right? You don't need it in Postgres. Right? Because what Postgres does is it has a native data type that handles IP addresses and subnets. And actually there's several of them. One of them being INET. Right? So if you wanted to run a query to find out every user that logged in from, I think 17,000 is Apple's public IP subnet. Find out everybody that logged in from Apple over the last 7 days. It's just a simple operator. There's no complex parsing or anything where you're able to query off of those IP addresses. Right? That customer was able to just change their queries to have a simple where clause as opposed to calling complex packages in order to be able to parse everything. Exceptions. So this usually comes over from, the migration tools do this all the time. So in Oracle, when you're writing your stored procedures, you write your functions, having the use of exceptions is standard practice. It's just there in every single stored procedure that I see that are coming over from Oracle. And they just translate it. So if we had this function in Oracle, get first name, that's just going to return the first name if it finds it by the last name in the table. If it's not found, it's going to return null. Right? If you're going to convert that over to Postgres, right, this is the same function. One of the really cool things about why people would like to move to Postgres from Oracle is if you look at the differences between these two, it's just the header and the footer there of it. It's the same code. Right? That really came from the original developer of PLPG-SQL, Jan Vik. When he was writing PLPG-SQL, he had an Oracle book on his desk. So if he wanted to find out how to write an if statement, he looked at how Oracle did and said, that looks good. So that's what he did for Postgres. So it makes these sort of migrations go very simple. The problem is exception handling is different in Postgres than how it handles in Oracle. Right? So what Postgres does is under the covers to be able to handle these exceptions is really create like does it via sub-transactions. So it's like if you had some hidden save points. This is kind of pseudocode that kind of walk through what happens. Right? So for that given function, it would be creating a hidden save point before it ran that select statement. Then if there was an exception there, it would roll back to that save point and do what's in the exception handling code, or it would release that. Save points are very heavyweight. Sub-transactions in Postgres are very heavyweight. And if you have a lot of concurrent sessions all doing them at the same time, you're going to have a big performance hit. Right? But most of the time, you don't need exceptions in Postgres. Right? So if you were going to run this function and you got a not found, right, it's still going to return back null. Right? So if we remove that exception block and ran that, get first name for Jordan with a capital J, we get back Michael. Get back Jordan with a lowercase j, we get back null. Right? Didn't need exception handling to do that. Right? But reality, what's happening is not all exceptions that you expect in Oracle are going to be Postgres exceptions. So if we did this, instead of returning back null for the return value, we're returning back the string not found. So if we did that, right, and tried Jordan with a lowercase j, we still get back a null. Because for Postgres, for a select into, it's not going to throw that exception, no rows found or too many rows, right, by the way it works there. Right? If you want that behavior where it's going to throw that exception, you have to use the strict keyword. So that's something that a lot of the tools don't get right, is well, to convert over to select into, and there's an exception in there that you really want to be able to catch for the too many rows or no rows found. You have to switch that select into a select into strict. Right? So with that, we're able to get that not found for Jordan with the lowercase j.
Okay, what does that do? What does strict do?
What it does is that means that it'll throw exceptions for the no data found in too many rows. Otherwise, it won't. So data types. This is one that everybody makes, right? It's, I've never seen somebody go through a migration for their first time and never make a mistake on the data types. Part of the reason why is Oracle really only has a few data types that people use. Varchar 2, date, number. Occasionally you might have a clob or blob. Right? For Postgres, by default, you have 64 base data types. You have a lot more options that are there. And you could create many more. Right? So there's extensions inside of Postgres that'll create a lot of different data types for you. Right? So you have a lot of different choices that are there. And really what it is the perceived equivalent of an Oracle data type is not necessarily the same as what it is on Postgres. Right? So people think of a clob as a big text field. So they see a text field in Postgres and think it's the same thing. It's not. Right? For a clob inside of Oracle, you have to use special packages to be able to do things like get the length. Right? In Postgres, a text and a varchar are the same thing. The same underlying code runs it. Difference with it between a varchar and a text is a text you don't have the length qualifier on there, whereas a varchar you can. You could optionally put to there. So if you have a varchar without a length on it, it's essentially the same thing as a text field. And you could have the length qualifier of a varchar be up to 10 megabytes. So you could have a 10 megabyte varchar and check the size of it before you, and put the constraint on there to be able to push it in. But you can have a varchar or a text field go up to 1 gigabyte in length total. So you could have a 1 gigabyte varchar or 1 gigabyte text. They're the same thing. It's not different like a clob, right? They are the same thing. You could use the same sort of length functions on a varchar or a text field, no matter how big it is. So in this particular case, we insert in 1 billion X's, right? That's what this is doing. So 1 gigabyte size into a varchar. And we could just run the length on that in order to be able to get it. No special handling, whether this varchar was 100 characters or 1 billion characters, the same length function works across them. No special handling, it's just a varchar. Text is the same thing. Right? In some ways, a text field is faster than a varchar in Postgres. Right? So if you're looking for sheer performance, you'd want to use text fields, not varchars. There's less overhead on the text field. There's a little bit more wrapping around a varchar than there is on a text field. So the native implementation of Postgres for any sort of string is a text.
But with varchar, you can do a pre-allocation, so you never need to do any mallocs.
Not in Postgres.
That's what we do in MariaDB. So
Yeah.
for us,
Yeah.
it's a big difference.
Yeah.
So basically, log is dynamically allocated things. We need to do a malloc every time.
Yeah.
While with varchar, we do nothing.
Yeah. For Postgres, basically a varchar is a wrapper around text. Right? So this is the one that I see everybody get. From Oracle, you're migrating over, everything's a number, your primary keys, your foreign keys. You can have up to 38 digits, right? For Postgres, with all the migration tools, they convert it over to numeric. They sound like they're the same thing, right? You could have 38 digits in numeric. The difference is with Postgres, there's more. It can get bigger and bigger and bigger and bigger. So the same gentleman that wrote PLPG-SQL for Postgres also was a German banker who really cared about the precision of financial data. So he created the numeric data type, which could support up to 131,000 digits. Right? A number in Oracle is not the same thing as a numeric in Postgres. Right? They're very different. It could support 131,000 digits before a decimal point, 16,000 after the decimal point. Storing your primary keys in a numeric in Postgres is like storing your email address as a clob in Oracle. Right? It is complete overkill. Right? So just as a simple example, taking two tables, T1, T2, and we're going to insert million rows into one, 10 million into the other, right? And we're going to join them as numerics. And we get that, just a simple example here on my old laptop, took 2.7 seconds. We do that same thing as big integers. So the size on disk is identical. Right? It's down to 1.9 seconds. The difference is the equality operators for a 8-byte integer compared to the numeric, which is the arbitrary precision like numerics. It's a lot faster for an equal operator to find out if they're joined, right? That when you're joining those 10 million rows, it adds up. So when you never use a numeric for a primary key or foreign key, use a big int, right? And if you don't do this in the beginning, all of the stored procedures that convert, and you have them all coming in with parameters, numerics, and other things, they're all going to be casting along the way, that you're going to be casting numerics to big ints and then back again. You're going to see performance differences, 20, 30, 40% difference between using numerics versus big int total over your application. Like, the first thing you do when you're converting from Oracle to Postgres is get the data types right, because that's building the foundation of your entire migration project, right? And if you use numerics from the beginning for pretty much anything other than financial data, you're throwing away 20, 30, 40% of your total application of what you could be getting out of Postgres. So just kind of wrapping it up, most of these things are simple that people bump into. The second migration they do, they never make that same mistake twice, right? Especially that data types when they're trying to perform, they're running performance benchmarks on Postgres after they've been working on the project for a few months, realize that they're not getting the performance they want to, they convert it over to big int, and then they have to go back and touch every one of their stored procedures and sometimes even their application code. Like the JDBC driver, the JDBC Java code getting back an integer versus a number is different, right? So you have to do that right from the beginning, otherwise you're going to be doing double work. Some of them are simple, like the dual table or synonyms, but really you want to be able to get that data type stuff right from the beginning and get the right one. Don't be afraid to use Postgres' native data types for things like IP addresses, UUIDs, right? You know, something like a UUID, native UUI data type is a lot smaller than storing it as a varchar, and it's more efficient. Okay. With that, thank you. And if anybody has any questions, I'm here. John?
How much does the, I guess, Enterprise DB has the Oracle extension stuff.
Yep.
That Oracle compatibility extension. How well does it actually work in your experience? Like how much stuff do you, is it really just like 90% of stuff can just drop in? Or?
A lot of the Oracle compatibility is around the built-in packages. Right, so Oracle, especially in the 90s, wanted everything run inside of an Oracle database. So everything that you would think to do today in maybe the application server, they pushed into built-in packages inside of Oracle, whether that's kind of manipulating files to queues, right? They built them all as internal packages. So people over the years and decades built in using that, and EDB has a lot of the built-in packages that make those migrations go a lot faster. Things around like the parser changes and other things like the plus sign for outer joins versus the ANSI thing, it's like, okay, you could kind of go change that. That's really helpful to get there. But really the built-in package stuff is a lot of the stuff that you see in the Oracle applications, especially the really old ones that are really difficult to move. Right, so it does work. It's not 100% like any sort of compatibility or migration tool, but it does help a lot. Right? But also think of it in context of a migration project. The overall length of a migration project, the actual code of migrating the stuff from Oracle syntax to Postgres syntax, depending on how complex it's, somewhere between 20 and 40% of the overall project time. Most of it's QA, benchmarking, set up Postgres in the new environment. Like you still have to do that regardless of how much you save on the migration cost itself. So it kind of depends on what your end goal is.
So I came in late, just the second thing that, if you're speaking on the topic, I don't know if you covered the available tools for handling a lot of the heavy lifting of this, and if not, like what's your favorite one? Or TTE, or like, it's like
Yeah, there are a bunch of them. AWS has a schema conversion tool, which is a client-based tool that does the migration and conversion for you. Or to PG is a very good tool that's open source that does not only the migration but also an assessment by scanning an Oracle schema and give you an estimate of how much effort it would be to migrate. Is there any really hardcore Oracle stuff in there, or is it mostly ANSI SQL that goes quick? From an open source standpoint, that's one of the best. Aura to PG, Aura the number 2 and then PG. Works really well. Yeah, it has been, and it's version over version, it gets better. I believe that one's GPL licensed. I've been using that one for a long time, works fantastic. Right, so it's there are other commercial ones out there, but from an open source standpoint, that's the best one. Any other questions? Cool. Thanks, everybody. Enjoy the rest of the conference.